Warm welcome to all our listeners and the speaker for the day, Rumi Engineer, sir. The team here with me from IEAR and CTES College of Architecture. This is an occasion where we are looking forward to your participation for the next 1.5 hours. I am Professor Pushpagandha Shukla. On behalf of CTES College of Architecture, I extend our warm welcome to all our viewers and listeners. The webinar is a series of lectures. We had conducted a lecture yesterday in the similar time slot, and today we'll be conducting the extended second part of this webinar. This is a webinar which is in collaboration of IEAR, the Institute of Environmental Architecture and Research, and CTES College of Architecture, Chembur, Mumbai. ASSOCHAM Maharashtra chapter, we all warmly welcome all our participants and our speaker for the day today. Today's program is based on IEARs, that is the Institute of Environmental Architecture and Research, in collaboration with CTES College of Architecture, Chembur, Mumbai, and ASSOCHAM Maharashtra chapter. We are conducting this energy efficiency in buildings, retrofit management and policies. This is a webinar which is being conducted on eve of the National Conservation Day, which falls in the 14th of December week every year, and it has been observed by the Board of Energy Efficiency under the Ministry of Power. Today's session, we will be having Alka ma'am as our moderator and the conductor for the session. I'll introduce her briefly. Professor Alka Tafri is the principal of CTES College of Architecture, Chembur, Mumbai. She has over 35 years of professional experience in architectural design and management of projects and teaching. Architect Tafri has worked on a wide range of projects, including project architect for Ashoka Gardens, Shivri project in Mumbai, and has been awarded the platinum rating IGBC Green Residential for the by the rating systems in 2018. Planet Godrej, Mumbai, and several other projects have been undertaken under her guidance. They were spread across the metro cities and smaller townships also. I would now request Professor Tafri to take up the further session.
Thank you, Pushpagandha. A warm welcome to all present from IEAR, CTES College of Architecture, and ASSOCHAM Mumbai chapter. We are today delighted to have Rumi Engineer sir amongst us, who will be talking on energy conservation, and he will be giving us the practical knowledge and practices that he has devised. As we all know, most of us are architects and engineers who are involved in building engineering. We all know that the building and construction sector accounted for approximately 36% of energy use and around 39% of carbon emission related to processes related to building construction. Most of it came from production of building materials like steel, cement, and glass. Around 11% of these emissions came from this building industry. So we know that this industry is accounting for a lot of energy that is used by world. We all know that each building consumes a lot of energy throughout its life cycle. These energies are initial embodied energies in the form of processed materials, recurring embodied energy, that is the energy which we use for maintenance and refurnishing, operational energy, which is used for operations, and demolition energy, which is also required when we demolish the building. So the economy is cradle to cradle or cradle to grave, whatever way you want to call it, but it's a huge, it has a huge impact on world energy consumption. Per capita energy consumption in the world is growing very fast. Still, we know that around 10 to 20% is more used by the developed countries than the poorer developing countries like ours. So around 10 to 20% more. And we all know that when the building is heated, it takes a lot of energy. And most of the suburban homes in America use a lot of heating and cooling also. So that's why a single person using a lot of energy to heat up or cool the whole house, it requires a lot of energy. Global building sector emissions increased a lot from, we are seeing uh, a data collection and analysis from 2010 to 2018, and we have seen that approximately 19% more electricity was used than 2010 in 2018. Most of this energy was generated from fossil fuel like coal and natural gas. And that's why it is very, very important to for the world to move towards clean and renewable sources of energy and passive and low energy designs by the designers. Uh, Policymakers, designers, builders, and users, they all have to come together to make these issues known to the world, and everybody has to talk about it. India has started its own Eco Nivas Samhita, which is the first energy conservation code for residential sector. And there are some other countries in the world which are also making their own codes towards energy conservation. Japan and Canada are developing new policies to achieve net zero and net zero ready standards for buildings by 2030. Uh, Global ABC and IEA are creating pathways for most of the developing world. And the key areas are urban planning, new buildings, existing building retrofit, building operations, systems, materials, resilience, and clean energy. We have seen that floor space is increasing a lot, something like 23% from 2010. But the energy consumption is around, or carbon emission is around 19%. So there is not a correlation between floor space increase and energy consumption, but still, the moment the more floor is used, the more electricity is going to be used, and more electricity means more carbon emissions. Decarbonization of the electrical supply is therefore needed to transition the clean energy. And we must congratulate Godrej and Boyce to start working in that direction. They have entered into an into EP 100 commitment, and which is a wonderful thing. And Rumi sir has been instrumental in that. The main India is doing a few more small things like RMC, ready-made concrete, ready-mix concrete needs a green pro eco labeling in India, which is transformation, product information, performance. And so we are moving, tiny bit of steps. We're taking tiny steps towards green future. Everybody, can I be heard, or is there a problem?
No, we can be heard.
I can hear you.
Okay.
Please.
Work areas where people need to work more is awareness and education, public policies, market transformation, financing, measurement of energy consumption, data analysis, and data information, both. EIA's Outlook 2017 has projected that amongst all regions of the world, India is going to see the fastest growth in building energy consumption. They are saying that we are going to need around 2.7% increase every year from 2015 to 2040. This is more than twice the global average. So we all know now that the world needs to take caution on these things. I now stop my small presentation, and I want to introduce everybody to Rumi sir. Rumi sir serves as a senior general manager and head of energy management and green initiatives, Godrej Boyce Manufacturing Company. He has more than 30 years of rich and varied experience in sustainability, green building consulting, energy management services, operation and management, operation and maintenance, project management. He is lead AP, BEE certified energy manager, Griha evaluator and trainer. He is a working committee member of CII IGBC Mumbai chapter and lead faculty for conducting training programs on behalf of CII. I welcome you, sir, and we all are looking forward to your presentation. Uh, uh, Kindly take over, sir.
Thank you very
And
much.
Rumi sir,
Yeah.
I missed out on a very important welcome note. I had to introduce Roshni ma'am. So let me
Yeah.
do that with your
Please.
permission.
Please,
I'm
please.
sorry, I missed it.
Please, 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 please.
Yes. Roshni ma'am is a part of our team from IEAR. I would like to introduce her as one of the esteemed organizers who's co-hosting along with us. Dr. Roshni Udyavar Yahuda is a practicing architect and an academician whose core competency lies in energy efficiency and environmental design of buildings. Roshni has a PhD in resource management and is a qualified master trainer and empaneled expert in energy conservation building code ECBC of India and has been awarded by the Bureau of ECBC, the Bureau of BE and UNDP GEF in February 2018. Dr. Yehuda is a co-chairman of ASSOCHAM Maharashtra chapter, director Roshni Udyavar, and the associates of Mumbai Advisor, Environmental and Sustainability, Science and Technology Park, Pune. Roshni is the principal investigator for the Department of Science and Technology, Government of India research projects on developing energy efficient and the ECBC compliant opaque wall assemblies. She was head of the Rachna Sansad Institute of Environmental Studies Architecture from June 2003 to July 2017, where she initiated several environmental projects in addition to the postgraduate course on environmental studies and architecture. She has more than 20 years of academic and professional experience and has traveled widely on professional assignments to more than 20 countries. Once more, a warm welcome to all our team and Rumi sir. I hand over the speaking part to you, sir. Thank you.
Yeah, I just thanks Pushpaganda. I just want to welcome
Yes.
everyone again today on behalf of the Institute of Environmental Architecture and Research to this webinar on energy efficiency in buildings, retrofit management and policies, which is being organized as part of this awareness raising week of the Bureau of Energy Efficiency, Government of India. We have been doing these webinars since the lockdown of March 2020. We started there, and this is the 17th in that series in which we have organized and reached out to almost 2,500 participants. Just a brief about IEAR for those who have probably coming here today for the first time, maybe. That our Institute of Environmental Architecture and Research, is a Mumbai-based educational research and training institute with a vision to create sustainable environment through scientific research, education and training, socio-cultural understanding, community engagement and awareness. We are a registered public trust, and our trustees comprise a multidisciplinary group of scientists, professionals and academicians who came together to form this organization after having worked collaboratively for more than 15 years on education, environment, consultancy, and awareness. And our mission is environment first. So today is the second day of this webinar on energy efficiency in buildings, which is being held for 3 days, that is 10 to 12 December. And the topic of today is a very interesting one: operational energy efficiency through energy monitoring system. And I think there is no person better than Rumi Engineer to talk about this. I have been working with Rumi as well as with many other people from Godrej, including Godrej Interior, on various environmental, indoor environment quality as well as energy efficiency projects. Currently, we are working with Godrej Construction, and Rumi is one of our advisors on that project for developing energy efficient opaque wall assembly for warm, humid and hot, dry climate. This is for the Department of Science and Technology, Government of India. So we have a very good speaker here. I hope we can make the most of it. Over to you, Rumi. Sorry for the in-between thing. It's all yours. The floor is all yours.
No, no. Thank you very much, first of all, for inviting me. I hope I'm audible.
Yes.
Yes.
Okay, so I would like to share the presentation full screen. I would appreciate if somebody tells me if it is a full screen share happen.
Yes.
Yes, okay. So again, thanks very much. At the outset, I must thank you for inviting me and sharing some of my thoughts. Actually, this presentation is totally focused on the operational efficiency. I'll talk a little bit more. But what Principal Alka mentioned, I would like to extend a little bit more. See why this has gained a lot of traction across the industry. When I say not the manufacturing industry, it's the transport industry, it's the logistics, it's the residential sector, commercial, even a manufacturing industry like us. If you see way back in 2015, I just to understand and appreciate the present, it is to have some sort of an insight on the past. So what has happened, this global warming, I'm sure you're all aware of it. So there is a lot of talk and really conscious effort being paid to see that by 2100, by next century, we don't let the temperature rise by more than 1.5 degrees centigrade to pre-industrial era. Now, you may ask me, what is a pre-industrial era? It is 1890, so that is where the industrial revolution started. And if you see till 1940, the temperatures were really stable. After 1940 and 1960s, if you see, the temperature started galloping. So if we don't look at it, we will end up with 5 degrees or 4 degrees temperature rise, which is not at all sustainable. And it is going to impact the livelihoods of the millions of people, and more impacted will be the poor countries or the developing countries. Now, in that context, India has got a catch-22 or a very challenging situation. We are an emerging economy. We have to grow. And when we have to grow, obviously, there will be an increase in our carbon emissions. I'm not talking about energy. Now, everything you will see, your building, everything will be talking about carbon emission. So India has taken up a target aligning to Conference of Parties 2015 Paris Agreement, saying that by 2030, India will be reducing the carbon emission intensity. Please understand, intensity means there is a ratio to GDP to 2005 level by 30 to 35%. So that's a very, very tall target. But I'm glad to know, to tell you, inform you, you can go to the media. We have already achieved around 20% plus. So we are on the right trajectory. Good amount of traction is happening. Even to just give you what Principal said again, that we are the coal-based economy. If you see, major power producers is still coal-based. Now, NTPC, you must have heard of this name, National Thermal Power Corporation. Recently, there was a news. They have taken a conscious decision that any new projects or any new expansion, it will be totally a green expansion and not on a coal-based economy. So these are the policies, because I read the policy word inside your presentation material. So I said, let me talk about, so a lot of policy interventions are happening. Government has made a think tank which looks at all this action plan and etc. So there is a climate action plan, a lot of things are happening. So coming back today to our topic, I have captioned it, the power of information. See, today data is the recent oil. See how oil lubricates, it is the data today. So real-time monitoring and analytics, I'll be showing you actual case studies. I've tried to make it more illustrative, to make it understandable and more interesting. But before I begin, Rohan Parekh, I was associated with him. I really, if you want, you can go to YouTube and just click this. Powered by data, driven by profits. That's a very powerful statement. Because you be any institution, be it any organization, till there is no profits, nobody is going to believe you. So just energy, if you look at it, energy is very, very like opaque. It's something which is very imaginative. So now to bring down and correlate, to put some sort of an analogy, what I'm trying to project over here is, let us assume that you have got a building and somebody tells you that you have got a 10 lakh liters of water in the building. Oh my God, good, very good. 10 lakh liters of well, it's a wow, okay. Now, I add a little bit more dimension to that. If there are 10 flats with the same 10 lakh liters, then you will say, oh, then it is only 1 lakh liter per flat. So is it too less? Is it enough or is it too much? So these are the pertinent questions which comes to the mind. And then when we say okay, per flat, you have got only 270 liters per day, still today you may say, oh, 200, it's very good. But are you aware that how many people are dwelling inside the flat? Do you know what is the end use, how much is the wastage, etc., etc., etc. So I start my presentation with giving you an analogy of the water, which can be seen, which can be felt, which can be heard. Unfortunately, electric will only give you a shock. It cannot be seen, neither it can be felt. Same thing goes with the energy. So that is why it's a silent wastage of energy and electricity which goes on happening. So again, to just give you a profile of water use inside the house, okay, a typical, just to give you a flavor of it, okay. So you understand this thing better before I jump into this energy. So when we are talking about a buildings or even a factory, I'm going to give you two case studies for your simplification. There are three aspects which everybody looks at it, because you are from the architectural background, maybe somebody from the project management, somebody maybe from the operations. So design is obviously the first part which comes to the mind. Technology, there is a lot of technology evolution happen. Look at the simple thing I would tell you, LED bulb, okay, simple. So whatever that 9 watt or a 5 watt LED bulb is giving you the brightness, earlier you used to have a tungsten filament bulb, which is of 40 watt and 60 watt, where is 60 watt and where is 4 watt and a 9 watt. Dramatic change in, I am not going to give you more elaboration. The thing, the most neglected in the industry, okay, is the operational performance efficiency. So for example, again, I will give you a small analogy. When you buy a car and when you buy a motorcycle, how many people take the mileage every time when you fill up a petrol and check up that what is the mileage being given? You service the car, you service this thing. After 5 years, after 4 years, you see that what was designed, what was promised by the OEM, what you got on the first day or what you are getting on the fifth year, is it the same or how much is the deterioration? So just to give you an example, if you take a solar panel today, people are talking about solar. The thumb rule says the very first year, the depreciation is 3%. And year after year, you take a depreciation of around 0.75%. That is, you take any solar panel, okay, be it Chinese, be it German, be it anything. These are the thumb rules normally we work in the industry. So there is something we call it as a discounting factor. So all these things has to be monitored with great rigor. Now for that, we have a very systemic approach. So most of the time, people monitor on the invoice bill. That means the bill you get from your supply company. So we call it as a macro level state electricity board. SEB stands for State Electricity Board Inca. So you have a transformer loss, distribution loss, then you have got a centralized utility, what is street light, canteen, air conditioner. And then you have got a manufacturing process that is at a micro level. So from macro to micro, when you travel, this is how my entire presentation is formatted, and we'll go through it. So this is just to give you a gist. Your power supply comes from the grid. You have got a substation where you have got a meter. Then ultimately it flows to your campus, which we are showing you on the right-hand side, that is a factory. And then you have got your processes, you have got your equipment, chillers, compressors, meters, etc., for which everything there has to be a meter. And these meters are connected through today wireless technology, that is GPRS. And you have got a server. From the server anywhere in the world sitting down, if the time permits, I can log in and show you a live data also. Now, just to give you a flavor of our entire campus, see, this is how at a macro level, we have been able to understand our energy use. First shift, if you see, normal working day when I take 100%, on a Sunday, surprisingly, it is 44%. And even on a paid holiday, we have got certain paid holidays where you don't pay even coming on a holiday, it is 25%. On a second shift, it is 100, 41, 30, 155, 47. So these are the macro level, very macro level. Out of that, even on a normal working day, we have got a campus which is split on the east side and the west side. So we understand that 44% is on one side, the 55% on, even on a Sunday. So these are the ratios normally which we work out. And why this is being done, we will go a little bit at a micro level, then you'll understand. So ultimately, when you have to have a data management, how much is the data, what type of data, and ultimately with that data, what do you do? So the very conventional and the very popular way is at a strategic location, you must have a metering point. This I would not advise anybody to do it. This is the conventional way. This is only data which will end up into your draw. Ultimately, the essence is online real-time analytics, which will show you the case studies. Now, the very first, we'll start with this building, which is a net zero building. And we have got a lot of awards and accolades. Believe me, this is not the end of it. Recently, we have done an internal audit and we have identified still there is a good amount of potential of 20% reduction in the energy as of today. See, unfortunately, due to pandemic, since last 7 months, we are not having full operation. But taking the reference of the full operation of the last year, still I can reduce by 20%. The reason is very simple. This is a 10-year-old building. You can see it in 2010, it started operation. You know your mobile, you know your laptop. In 10 years, how much amount of the technology has leapfrogged, and how much amount of technology intervention and improvement performance has happened. So things have not, so we have only been able to do all these things by only looking at the operational efficiency. So this is something as much as we can do. But now if I change my chillers, if I change my pump, then I will get a lot of benefits. But when I have to do that, I have to go and approach to the management and give them some sort of a proof. So the proof in the pudding is in eating. Now, let me tell you this. This is started by Tata Power, that is our supply company. Believe me, on email every day at 8 o'clock, 9 o'clock sharp, automatic this report starts on coming. So I have got an hourly profile. Look at the profile, look at the ups and downs. You see that green line. At 9 o'clock, there is a dip. Again, there is an up. So you get an hourly profile, you get a daily profile, you get a projected also for the month. How are you going to end? What was the average of the last month? So everything, it's like when you're sitting in an aircraft, you have a cockpit view. The pilot has all the dials in front of him. At the same time, from the glass, he sees the clear vision, when he has to take off and land. So this I would take it as a cockpit view. Now I'm just showing you, this is also a report which has been customized and made by our own engineers. See, this is all where our intervention comes, because you may take help of any branded software, you may take any organization. I'm not advocating for any brand. Please understand, application engineering, I am again using this word, application engineering has to be done at our end because we understand our application. So we see why I'm highlighted two things. The only thing, monthly, I'm getting this data. So solar power, we have got a solar system of 120 kilowatt peak. And you see the solar power right from 11,499, which is in January. In May, it has become 16,000. The reason is very clear, because the sun is very severe. Okay. And then in July, because of the rain, it came down again to 9.8, and we are having this trend. So you have to correlate with your operations, with your weather, climatic condition. Now again, AC. Because of the pandemic, if you see the pandemic, the lockdown started from March, you see the figures really dwindling down. And then slowly after August, September, we have started our operations a little bit. So again, you start picking up. So these are the trend which you see in the monthly. Now, what used to happen earlier, we never had all these energy meters. We never knew. We only had the Tata main meter. So now if you see from 1,19,000 on the left-hand side, my consumption has become 53,000. In absence of all the columns on the right-hand side, what are you going to make out of it? Why this such a large variation has happened? Now you have got a very granular, microscopic understanding that where your energy is being spent. So this is something really important, and we have understood our application and we have configured it. Now this was a monthly reading. Now after the month is passed, if you ask the facility manager what happened, you never know. So here I'm showing you the latest update. That is, the yellow bands are the Sundays and the holidays. And 14, 15, 16 was a Diwali holiday. Let me tell you that. So if you see, there is a consistency of the solar power which is being generated, but at the same time, my consumption, if you see the AC plant, that is why I have highlighted in the dotted lines in the red. Okay, so you see these differences. The same thing I'm showing you in a very different format. This is understandable by anybody and everybody, even your financial CFO will understand. said, how much is the HVAC? That is a maximum. To our surprise, canteen was a second contender after HVAC. We also never knew. So after doing this breakup, after putting this metering, and after doing this online analysis, we came to know. Even looking at the canteen of 31%, the ventilation was 35%. And what was this ventilation? If you see it is the blowers. So ultimately, we have all got this dashboard. So this is my total emissions. How much is the rooftop? How much is my offsite which I'm getting? What is my net emissions? This is, you have got a daily profile. Here we have got a incoming and what is the distribution. So what is my transformer loss? How much is the reconciliation which is happening between the sub feeders and the main feeders? So that means you have got a difference of marginal only 0.9%. Even if you look at the breakup, elevators, everything daily which we are getting this report. Now, if you see, this is my solar and this is my total profile on a daily basis. So if you see how much is the solar, when it has started generating. So talking about the savings. So this is what we have got. The red is the total, green is the solar part. So we were a little bit surprised that at 12 o'clock and 2 o'clock in the night, when the canteen is not being operated, we are consuming 75 kilowatt, and that was because the blowers were running. So after installation of a VFD, we could reduce from 75 to 55 kilowatt. So 20 kilowatt of saving there and there immediately. So these are some of the ways which you see. Secondly, how did we integrate? We already have a Honeywell system operation in BMS. So what we did, our engineer sat with the Honeywell engineer and the software engineer, and instead of putting so many modems, we only put one modem, and we pulled the data right from the Honeywell itself, So this is how it's not just saving of 50,000 rupees, which I'm saving, but to manage and maintain this number of modems, etc., that also has been. So this is a very innovative approach. Now, this is, I'm sure everybody will appreciate. Everybody must be going in canteen at some given point of time. This is a very interesting study, let me tell you. See, month by month, see, we will say, okay, why we have to have online monitoring system? We can go and take the reading daily or so. Believe me, nobody takes the reading daily at the same time, because operation people have got their priorities. There is a breakdown. Today, you will take the reading at 9 o'clock. Tomorrow, you will take the reading at 12 o'clock. Another day, 5 o'clock. And then he will adjust the time also. Believe me, he's not going to tell you. Okay. So you will have a totally skewed understanding of your energy profile. Your online system, whether you're on leave or whether you don't take it, everything happens at exactly a time which you have been predefined. So if you see in my March, okay, my April was a lockdown. In June, our consumption shot up to 15, 15, 12, and 12. Okay. Now sitting down, what do? We were at home and we were monitoring everything from my home. We have also configured our report for a holiday. As you know, I have shown in plant 13. So in September, if you see, it is very surprising. On a Sunday, my profile is varying from 300 units to 125. I don't know, 195 units. Same thing for October. And if you look at November, except for the Diwali holidays, we have this profile. So what happened? We went a little bit in details. We said, let us look at the profile. Lo and behold, you'll see on 1st and 2nd and 3rd of October, daily consumption was 400 plus. In fact, I have not showed you in September, it was 600, 2-3 days. And then it came down to 200. This is the time when we started questioning. See, these are all automatic reports. Believe me, we don't have to do anything. It comes on an email. So this is the time when we question the people that why it is so much amount of variation, because the number of people coming and dining, cooking, everything remains the same. So if you see the latest, the November, we have been doing around 200 plus and 300. We have been able to bring it down. Now, if you look at it, you don't even have to get up and go to the site. This is what you see. This is the online data which I'm showing you. So if you see, this is the variation from 1st of 15. I'm just showing you some sample. So if you see, there is a potential of reduction of 200 units per day. Okay, if you look at it. And 200 units multiplied by 300 days at the rupees of 800, you have a potential of saving of 4.8 lakh rupees. That's a fixed cost. Now, what did we do? What did we do? There is no magical wand we have got. Only temperature setting, because earlier the temperature setting was as low as 18, 22 because of some reasons. We understand where is the timing we use, so timed operation, and wherever the areas which were not operational, people are having lean, we did a sequencing of the units and we made it inoperational. So this is what you see. I've showed you from 1st to 15, but on a peculiar, you see these two graphs, I will show you, look at the difference. When the consumption was 431, And when the consumption came to 222, you look at this graph difference, you yourself will make out that it was running at 80 unit plus on the left hand side on the top. And this is just running less than 50 unit plus. So all this sitting down at home, telling the facility people, telling the frontline people, telling our technician, go do this, look into this, we were able to do this. So sitting down anywhere in the world, you will be able to understand. It's like having a power steering. In good old days, you used to have a manual steering. You have to turn so many times to turn your car. So this is like just like having a power steering. Even when you are cooking, your blowers are on. So this is a ventilation system. Look at the energy difference. And look at this. This was really surprising. In month of May, nobody switched off the blower right from 20th of May till 31st of the May. Even during the night, you see the continuous blower was running at 9 kilowatt. So that means somebody forgot to switch off the blower. For this, again, we have done an automation. So sitting down, you can come to know a lot of things. You know that advertisement of that CCTV, sab kuch dikhta hai. So this is something like, I would say, this is our CCTV. Now, I'll just give you an HVAC case study. Now, this is of a CNC cum office room. So if you see in January 2019, and if you see January 2020, if you see the blue line is a chiller consumption. Against 14,000 unit, the chiller consumes 17,000 unit. Okay. So marginally 3,000 unit. But if you see my pump consumption, it was much lesser than January 2019 for January 2000. So because we managed to reduce the consumption in pump, we were just at 17. Had we had the same consumption what was in January 2019, we would not be at 17. Another thing, if you see how the chiller consumption is varying, your pumps is not following that same trajectory or the profile. So if you look at it in the month of June, my consumption was a maximum 30,000 unit, but my pump consumption was the minimum. But when if I see in April for only 24,000, my pump consumption was double nearly, okay, 4,800. So these are all the things which we look at it. But now you may say, if I'm showing you this graph, he said the things of the past, how can we catch it? No, it doesn't happen that way. So what we have done, daily reports, again, we are getting it. So I put this red circle. So if you see my chiller consumption, when it is around 600, you look at the chill water pump 127 and 151. Now, if you look at the 20th January, for the same chiller consumption of 600, my chill water consumption is as low as 93 and 81. Where is 93 and 81 and where is 127 and 151? You know why it has happened? And even if you see my auxiliary on the extreme right hand side, you see that thing on a dashed line that is 11% and 13%. It has come down to 9%. We have been able to reduce our auxiliary. So all these things has been formatted, but this is very interesting. Now I'm showing you this graph. I don't know, had I been interacting personally, how many can spot some sort of a anomaly, something wrong in this graph? See, I'll tell you what is happening. My chiller is being load and unload because it is January. It is a cold month, 5,500. My chill water pump is consistently at 3.22 and 4.7. But on the 1st of January, I showed for 594, my chill water consumption and condenser water pump, still it was high. You know what has happened? You see right in the night when my chiller is off, my chill water pump and my condenser water pumps are running right from 0 hours till nearly 7 hours in the morning. And then again, it is running at a constant speed, not modulating at VFD. Same thing I'm showing you a little bit in detail. My condenser water pump is as high as 4.8. My chill water pump, you see the modulation. It makes a difference. Even if I say 3.36 and 4.8, there is a great difference. So again, I'm showing you this. Now the same graph I'm showing you on the second. You know what has happened? You see this bottom graph. There is a big U you see, ulta U you see. From 4 units on the left-hand side, it has become 12.5 plus, 14 units and 13 units I'm showing you. You know why it has happened? In the third shift, there is a problem. Poor technician, he got so scared. He did not know what to do. So he went manually, and there are 2 pumps instead of one running, one standby. He started both the pumps, getting feared that one might trip. तो दूसरा तो काम कर लेगा, जाने दो, अभी रात को कौन सांप को कौन बुलाएगा. So these are the things which happen in the industry, and then when they forget in the morning, we get this immediate information and we take this corrective action. So on the 20th of January, you again see everything is streamlined, where our consumption has come to 93 and 81. Why it has come down? There is no magical wand. but this is a conscious effort of monitoring and immediately action taking place. And even your chillers are running today. Do you know what is a chiller efficiency? So we have put some BTU meters. See, these are some wrong readings, and specifically I have circled in red because this is a duty of an engineer, not just to think that, oh, we have put BMS, we have put EMS, all the data is coming. So it is like a one pill which will cure all my illness. We call it as a panacea in English. It's not like that. We have to look and say, boss, this is something going wrong. If you see on a daily basis, my consistent efficiency is 0.53 kW per ton. So to generate 1 ton of cooling, I am consuming 0.53 kilowatt. So this becomes my benchmark. You will see some very absurd and abnormal figure of 13 and 4.99. Specifically, I have highlighted because these are the times which you will have to seek why these things are going wrong. And you get all this data. See, every day you go on getting this data. It hardly takes 5 to 10 minutes, once your eyes are tuned. And from this data, immediately when you see anything jumping up, see here also, this is the November. You see the chill water pump and the condenser water pump, it is 80 and 81 consistently. The moment this figure jumps up, immediately you have to open that software and see where something has gone, what is the time, and immediately you can tell your frontline people, technician people, and do the correction. So this is how your graph also. See, nobody has got time. We don't have the manpower to look at the graph. Only thing when these graphs are looked at it, when we look at all these things, when we see this jump happening. So this takes hardly. In fact, at my table, I get around 15 to 20 reports in a day. I spend around half an hour. It is like a hygiene factor. When you get up, you have to go and brush your teeth. So something like that, we have put the rigor with our team. And again, I tell my team, this is something, a very hygiene factor, you will have to look at it. Okay, so with this, what are we talking about? Savings, okay. So energy saving, if I say 100 units also, if we are going to mismanage, and if you are not looking at it, it continues for 300 working days. So you are again spending around 2.5 lakh. This is coming to 25 metric tons of carbon equivalent in a per annum. So ultimately, what are the things which you are looking at it? Specific energy consumption of a chiller, kW per TR, VFD operations are happening or not. You don't have to look at it. You don't have to look at all those rosy graphs. The report itself will tell you. It's like, when you do your medical checkup, a good doctor looking at this, then you will say, okay, then you do more tests so that you get into the details. So you have to correlate a lot of factors, okay, a lot of factors, a lot of metrics, a lot of dimensions. So again, in a medical profession, it is a very similar. So operations, chiller set points. If your set point is 12 degrees, 15 degrees, 18 degrees, it will matter, and time operations. Now solar. People are so happy. People are so happy. Believe me, when you put a solar, you do an inauguration, you put a garland, you put a nariyal and all that thing, and you come back. You know what happens when you operate the solar? See, again, I'm sharing you a case study. We have put a solar at a STP. When we put, it was contributing to 22% of our total power consumption. See, on the left-hand side, we have got total, how much is from Tata, how much is from solar, and you know what is the generation from. Now, from 22, today it has come down to 11. Believe me. That is, again, we have flagged it off. What is happening? Now, if you see my site, it is covered by trees. Now, what has happened, I'll tell you. Because of the rainy season, because of the lockdown, we don't have the manpower. And some negligence has also happened. We have not been able to trim the trees. It is not so easy. We have to take forest department permission, and a lot of things are happening. And we have also institutionalized automatic water sprinkler cleaning at Mohali and Shirwal. We have got 2.6 megawatt of plant. It is not kilowatt, it is 2.6. And we were wasting water with a bucket, we go and a splash of water. So 50% of saving and 7% of efficacy improvement by doing automatic cleaning. It is only 5 minutes, so everything is now done properly. So what has happened? This is the online software of this solar panel system. You see the dark shaded panels on the right, which is not getting the sunlight. So I'm showing you this. You can sitting down again track. You don't have to go to the site. At 9:30 in the morning, you see those blue. You see the numbers 100 plus. Each panel is also displaying how much unit it is generating at that particular point of time. I'm coming to 1 o'clock and I'm showing you. That is on 12th, 4th of December, 3rd of December, 5th of December, 6th. It is recently. So every day you see the similar profile. And you can see 200 plus at 1 o'clock in the afternoon. But on the right-hand side, you see it is again a dark patch. So it is not getting the sunlight at all. And at 5 o'clock, Lo and behold, again, you see the solar irradiation coming down, but again on the right hand side, in 24 hours, it is never getting the sunlight, never. So ultimately, if you see, that's what I have shown you, the reason of this coming down to 11% is nothing but this, and you have been able to track. Okay. And we know we have given this information to the concerned department. You have got certain protocols to follow, but we know the reasons. And this is how you can track your solar on the rooftop also. Unfortunately, this is not on the rooftop. Now, talking about these rosy dashboards and widget management. So I'm just giving you a case study of our manufacturing plant. See, when you have this type of a widget, you know what is a widget in mobile or Excel you have. So these are tree transformer. It just gives you a very indicative indication that how much is your loading of a transformer. These are the widgets we have actually customized. Now, our engineer has said, understood the application. But the same information I'm showing you in this data. So the tree transformers, how they are loaded, how much is the DG. I'm not showing you the DG. So it is telling you the figures. The third widget is actually telling you how much is a percentage vis-a-vis from 2nd to 8. The time frame remains the same. That is for 1 week, 2nd to 8th of December. This much is my consumption of total factory. Transformer 1 is constituting 32%, 24%, and 40% respectively. You can have a time of the day profile, you can have a daily profile, how it is happening. So these are the flexibility, these are the offerings which are there in any software. But the only thing is, as much as you develop those, see, these are not coming ready-made. Why I'm telling you again and again, this will never come ready-made. You have to develop it. So you require some sort of an application engineering and understanding of your operating systems. Here also, I'm telling you, we have got total meters. So how much area is still unmetered? So 13% remains unmetered. I'm still having an accountability of around 87% of my energy used in a manufacturing plant. Out of that, 20% is used by the compressor. See, compressor is the costliest form of air in the industry. So now I'm just showing you this. There are 3 compressors which are running. Okay, I made it quite simple. So compressor number 3, if you see the red one, it is getting loaded, unloaded, loaded, unloaded. You see that graph. If you see the right-hand side, that blue one, it is consistent. It is not unloading. If you see the C1, it is also not unloading. So 3 compressors are running. 2 are running at full load. 1 is loading and unloading. I hope I'm able to express myself. Now, same thing, we started getting this, what is the total time after 24 hours, how much is off hours and how much is loading hours. Do you see there is some anomaly? There is a wrong information which is being displayed on the third block, that is compressor 3. They are saying the unloading hours is 0, which is not at all possible. If I see this graph, okay, and if I see this report, there is an anomaly. So again, purposefully, I'm showing you this graph saying that one has to really validate that whatever the information you are getting from the dashboard and whatever you are getting in the report, is it in consonance or is it in dissonance? So this is something really important. So I would say, believe me, it's a full-time activity. Lot of people in green building, in lot of industry, they say, okay, yes, we have put energy management system, building management system, and there it is, everything is done, finished. No, sir, no, it doesn't happen that way. And this is where you have seen ample example, right from a building to a canteen, to developing a widget, to the solar, to the industry, you see a tremendous benefit. Now, same graph I'm showing you, you look at the load unload profile, C2 again. But here I'm showing, seeing 14 minutes of unloading time, if you see. Yes, this could be possible. And you see the variation happening from 68 to 130 units. Now, why you are doing this, you know, this is an old compressor. And the team, this is located in Chennai, let me tell you. And we are all coordinating on the teams and on the phone. They are after me, sir, we should put a VFD. See, putting a VFD is a no-brainer. But first, you have to understand what is the profile and then decide. Otherwise, VFD will not work. If your loading, unloading time is not significant, your VFD will not give you a benefit. So the whole exercise which we are doing is this project. Now, the last of this case study which I'm sharing, this is helping us tremendously when we go to the management and we say we want to take up a project. And this will be the investment and this will be the saving. Any management will say, show me the proof. Okay, so this is not Mr. Rumi Engineer speaking. This is the system which will speak for itself. It is not something on an Excel. I'm putting the figures. So this is the report of a compressor which we are getting on a daily basis. And this is 2019 and 2020, two comparison. And we have got two compressor house. Now look at this in 2019. Look at compressor house number 1. Again, we are talking about specific energy consumption and not absolute. This is very important because my consumption will go up because of the building use, because of the production, etc. But how much amount of output and how much amount of input which you get, that is very important. Then whatever it is. Okay. So if you see in both, there is a dramatic difference. Same thing, you see the consistency over here in 2020 also. But because of the pandemic, there were certain issues. You may see a little bit change in the figure. So ultimately, I'm trying to show you, and this is what we have projected to the management. And this is not something which we are putting it in Excel or you're doing it manually. Everything is automatically driven. So if you see the compressor number 1, it is a standard efficiency is 7.49. 8.46 is the high efficiency which you see, okay, in the previous slide I showed. So 12% improvement. Now my consumption figures with the standard efficiency is around 18,38,000 per annum. This is what I have got a record of past 2-3 years. If I take 12% improvement, that means I am going to save 2,20,000 units. Carbon emission is 184 metric ton. See, now we are going to go towards net zero or reduce our carbon emission intensity by 60%. We have taken up a target at a company level by 2030. Okay, 60%. Okay, so this is a tall target resting on our shoulders. So monetary saving is around 17,60,000. The new compressor, high efficiency compressor, we have already installed last year and we have got a proof. Okay. So you see 30 lakhs is the investment. My returns on my investment, the money which I'm going to invest, it is going to come back within 20 months. This is a simple calculation which we have put to the management. Today, there are financial stress which all the organizations are going ahead. It has been kept on hold, but immediately then we'll be getting the approval. Okay, so we are going ahead. Now, just to show you, okay, these figures which I showed you in a tabular format, this is in 10th of August, I'm showing you till 14th of August. Okay. You see this high efficiency. We are generating 9.9 units for 1 unit of energy. Look at the standard efficiency. I'm generating 7.5 and as low as 6.5. Consistently. You look at it. Even today, recently, you may say, Arey, you are showing me a past figure, August. Okay. You see very recent figure, 7th of December. I said, okay, let me show you this recent figure. You see this consistent. And to understand, we have put that baseline of 9. So anything above 9, that is nearly 10, you look at the dramatic difference, okay? And we have got other compressors. So these are the widgets, these are the dashboard, which really helps you, which really supports your projects and which will really strengthen your hands to take this thing matter forward for the approval to the management. Now, even how much amount of a generation, how much amount of a consumption, and how much amount of a loss. You see this also. So this is also not consistent. There are various reasons. I'll not be able to get into the specific because of the metering issues. We are working in 3 shifts, loading, unloading, deadband, a lot of things are there. But at least we have the figures in front of our eyes. Nothing measured, nothing can be managed. You know all about it. So ultimately, coming to the end of this entire presentation, which I have taken to you. So the challenges which you will face or one faces or we face, you have to have a clarity in scope of work. Believe me, in one of our divisions, we have got 150 meters installed. When I asked that facility guy that 150 meters, what are you going to do? What are you doing with it? The answer is, I don't know. So investing on 150 meters, but not understanding what is the output which you are going to get it. See, like in medical terms, you may do so many tests, okay, but you don't know what to correlate and what to do out of the test. You may do the test every month, medical checkup, which will cost you 10,000, 6,000. But what good it is? It doesn't tell you anything. Okay, till you know that yes, you are suffering from certain thing. Like those people who are suffering from diabetes, they've got a small machine at home. They have to keep their sugar in check and take the medicines. Okay, action. So all meters should have 485. So if you've got an old meters, which is not having a communication port, okay, then this will not, you have to compulsory see what is 485. Meters have got register inside. So these are all technical aspect. You will have to share with the vendor. You can sit good amount of network strength of the connectivity. You must have a good signal strength. Otherwise, these are all wireless. Validate the meter as I've shown you at the meter and the software end. So meter will show you something, software will show you something, your report will show you something. So this type of validation which have to happen. Data adequacy. You calibrate the meters for ascertaining its accuracy of the output delivered. Must also have the single line diagram. Many a times you'll have sub-metering in such a way that otherwise you'll end up into double counting. You'll have this meter plus this meter, but this meter is to be subtracted or to be added, you don't know. So we call it in our language single line diagram, distribution, how the distribution of the power network is done. And reports, again, validate. Dashboard widgets has to be configured, customized to own's requirement. So ultimately, handing to that, it's very user friendly. I've shown you, only thing, yes, you must have a dedicated person from your end to collaborate, coordinate, and with your team and the vendors team to develop live monitoring, overall energy and carbon dashboard, asset. See, many times you don't know whether to buy a new chiller, buy a new pump or not. So assets which you are having, have you utilized to its full efficiency? What is your asset performance management system? Okay, we call it APM. And project feasibility, I showed you the last project that when you are doing your projection feasibility, and you don't have to do anything, automatically all the reports will be generated. We are also working on alerts. Supposing your daily consumption is 10 units, the moment it goes above by 20%, you will get an alert on your mobile, you'll get an alert on your email that we are working on it, and periodic reports, everything is done. So I think so. This is something which I hope I'm able to cover and convey the right information message and convince the people, those who are attending that it is really a very important tool, because performance management is a very silent, not much talked about it. So this is something like, you give me enough amount of software, you give me enough amount of meter, I can move the world. So that's what Archimedes said, give me a lever long enough and a fulcrum, okay, on which to place it, and I shall move the world. So, world will be at your feet. Okay, you can at your fingertip, whatever is happening to your premise, and you'll have a total control, so as much as you want to do it. So thank you very much. With this, I end. Thank you very much.
What a wonderful presentation, sir. This is what is needed from really an engineer.
I'm sorry, I was telling Roshni, I'm very poor at making such articles, but I can give you this information first time.
No, sir. I'm really amazed at the meticulous data analysis that you have done. It's a wonderful thing. Probably it's an eye opener for everybody that data collection is very easy, sir, but not many people know how to analyze the data and how to reach at a conclusion, which you have done so wonderfully in all your readings. I'm really amazed at the meticulous understanding of things. And this is what is very important for all the people who are attending this webinar, that many times the data is collected and it is just posted like this. This kind of understanding of the data is something I think everybody should do. And you have taken us on a journey from pre-industrial era to to current situation, and yeah, it's really amazing how you are trying to manage the whole campus, analyzing the canteen, because that's where most of the time people stay, and you will come to know that why people are spending so much of time there. Probably during lockdown, because they were not bringing food, they were spending so much time in canteen. That's what your energy consumption showed, that May, June, July people were spending a lot of time in your canteen.
Yeah.
And yeah, so this is
Sorry,
how,
this is
yeah,
something I would like to tell everybody,
yeah,
that this entire EMS system has come to our rescue and our help most in this pandemic situation, because all our team, even
yeah,
our technicians, were sitting at home. And
uh-huh,
today everybody has got the internet. And we
yeah,
were just watching, and we were just discussing on the teams and saying, hey, look, something has gone wrong. The modem is not working. So then someday our technician will come, he will switch off, reset. We will tell the operational people, look, something is going wrong. Why don't you go and have a look at it? So this has really, really helped us a lot in this 7 months period. Sorry to interrupt. You can go on.
no, no.
Sorry.
I mean, I was really amazed at looking at each and every chiller, each and every pump, each and every. I mean, everything you analyze, and probably with your experience, you know things on your fingertips. But yes, if people start analyzing data like this, they will know where to start thinking, taking note, and where to move towards, energy saving and an efficient energy management. So it was a wonderful presentation, sir. I'm really honored to to go through the data and to look at the analysis.
I
It
can
was,
share this presentation, not an issue,
yes, sir. That will
because
be
it
a
is
wonderful thing.
more on a academic note. And
Yes.
lastly, sorry, I didn't cover up one part.
Yeah.
See, actually, again, I'm not advocating any brand.
Uh-huh.
See, the one which we have selected, it is software as a service. I
Okay.
hope everybody understand what is software as a service. See, now a lot of branded products are there. They say, okay, you buy my software for 3 lakhs and
Hmm.
this is my service. And I've got a very limited license. 10
Hmm.
people can do, 5 people can do. In
Yeah.
our case, no. Meter is ours,
Hmm.
connection is ours. For each connection of a modem and integration, there is a charge and there is a AMC. Okay, so tomorrow if I shift my meter from Bombay to say Mohali or to Chennai,
Hmm.
meter everything remains the same. Okay, only recommissioning charges are there, and per meter I'm paying them a very nominal fee. So as many meters I go on integrating as a modular approach, only my spend increases. I'm not spending a bomb at one time of taking a software, and the software is residing on a cloud. Managing the software, updating the software, there is no liability on my head. So this is a very good system which we have selected after looking at lot of merits and demerits of lot of products. Okay, so this is something I would like to share. So it is very cost effective also.
Uh-huh. Uh,
I may
another
just
thing that, yeah, yeah, Roshni.
explain about the presentation. I think yesterday we had Bruce, who talked also about one of the systems for improving efficiency is about the IoT of things and BMS and all that. And he said there is a 3%. There is a scope of 3% improvement in the energy efficiency that you can do year over year, and probably much more.
I
And
agree. Yes.
when you shared that your plant 13, which is already net zero and all that, and it is still improving, you said there is still scope for improvement. So that is really fantastic, because people, when you go for audit, they say what is there. You just give us the solutions, and they don't look at those fine numbers that you have been looking at and giving the solutions. So that makes such a big difference.
Yeah,
It's
so
not.
Roshni, my challenging task is just beginning, because I have to put to the management and say, I will require some X amount of money, maybe a crore or some lakhs of rupees to change the chiller. The moment I'm going to say I'm going to be short, Dad, not at this time. So I'm collecting more and more data, and it is the data which will speak and not me. I put that. I'll be at the backstage artist and putting the data in the front, people. So no,
Yeah.
this is really the fact, because 10 years back, whatever the chiller efficiency, the pump efficiencies which we have got, you all agree, we have got a good, tremendous scope. So we are doing some sort of a very cautious approach. Just now is not the right time to put a proposal, but this data really helps everyone. So I would say, look at it seriously. If anybody needs help in implementing or getting some assistance done, then we'll be too happy. So look at this as a project, okay, and we can help people with
Yeah.
our expertise.
And I know of many companies and buildings which are so-called smart, which have all this BMS system, but nobody is nobody is actually monitoring and doing something about it, which is the sad state. Because that is where the challenge is, to find out where the energy is being consumed, why it is being consumed, doing the ground reality check, and then making the change. That's the important aspect, not important just to have the BMS.
Correct.
Another wonderful thing that I noticed was, the larger system is centralized, but monitoring is kind of decentralized because you're putting so many meters. So you are minutely monitoring things, which is where if you have a larger system and you put 1 meter, it will give you a generalized reading. But when you start noticing things, that why this is like this, why this is like this, then only you are able to improve the efficiency. So that was also a wonderful thing. And second things are your solar panel analysis. I mean, so many times we do that the solar panel guy will come and he will tell you that, yes, west side, this is where we'll put the solar panels. And but this kind of minute analysis of why your solar solar panels are not giving you enough solar energy, uh, this is the mind of uh, I actually wanted to appreciate, but this is the mind of an engineer. So you have
no, see, actually, what has happened, as I told you, we all have got targets over here. Now, when you have got a predefined targets, obviously, we will have to have some sort of a measurement system. Otherwise, tomorrow we cannot say that. So that is why we have got monitoring system of the entire organization. We have got a plant in Chandigarh and Goa and Chennai, East West. So we have got all the system integrated. So sitting down over, and we have assigned one engineer responsible. 80% of his KRA or KPI result area is to work upon this. That is why we have been able to get these results.
Yeah, no, it was a wonderful, wonderful thing, sir. Wonderful thing. Now there are some questions. With your permission, I would like to start.
Yeah, sure.
Yes, sir. So the first question is from Sunanda Satwa. She is a faculty at CTES College of Architecture. She is asking, what is the information system or software from Honeywell that captured the canteen data?
No. Okay. Let me tell you. See, I think so. Sudanna ma'am has come and visited this building. So she has correlated that canteen which is there in this building. Now, this canteen project which I've showed, there are two canteens. One is on the west side and one is on the east side. Now, this canteen is not on under the plant 13 building. Okay. So this is a totally standalone different canteen, but is air conditioned. Okay. So that is what we have done a case study. Now, in the plant 13 NX building, where she may have visited, I presume, that canteen is very different. But plant 13 NX building, we have got all the details of the blowers, the solar system on the canteen, and all the things which I have shown you in that report. So that also we are monitoring. We have done that blower project in that canteen in plant 13 building, when in the night also the blowers was running at the fixed speed, which is not required. So we have been able to tune it.
Okay. Sunanda, does that answer your question? Second question is from Harshada Punde. She is also a faculty at CTES College of Architecture. She is asking, what are the various energy usage monitoring systems available in India?
Okay. There are various monitoring systems available with all the branded companies. Like if you see Johnson Controls, and if you see Schneider, and if you see as biggies as IBM and ITC, a lot of people are there. Even Tata Consulting Services and all that. See, again, please don't misunderstand me. Let me put it in a very plain and simple words. We have gone through all the presentation we have seen. Now, what happens in our case? We have got certain limitations as far as our manpower resources there, monitoring and all that thing. There are a lot of high-end predictive analysis systems also available. Okay, so we went through all the presentation we saw. So we saw, let us look at our application, look at be modest, and the investment which can be scaled up gradually. As I told you, today you can do 10 meters, tomorrow you can do 20 meters and all that thing. So this party which has offered us the solution worked out the best. Okay, work out the best. Even, okay, what Sunanda asked was this Honeywell system which we have in plant 30. That was when the green building system got installed and it was there. Now, we institutionalized this system later on, hardly 2 years back, 1.5 years. Now, we would have duplicated this system data, and Honeywell are also getting this data. So that's what I showed one slide, innovator. Whatever the data which we are getting from the Honeywell, we pulled the data and we got it through this system. But that was not very easy. We had to do some sort of a trial error. It was a risk whether it will work, it will not work. So we took a small group of meters. Then we had to validate. Our engineer had to see the readings coming from the Honeywell. Our system is really telling. That is, we call it the data adequacy and all that thing. So there are dime a dozen software people are. I'm not saying that this system is the best which we have selected. You can select the brand. You can go with Schneider. You can go with Carrier, anything. The only thing, the key in success lies is that you will have to have one person from your end, knowledgeable and a single point of a contact, like an anchor who will coordinate. He will be like an orchestra, conductor. As you have lot of people playing the orchestra, he will be the center point who will be managing the system. If in absence of that, you will not realize this much amount of benefit, be it any branded product. Okay, all are good, all are good. So I am not advocating only thing is what we found is beneficial was it was like a software as a service model, and slowly we are scaling up. First we did 100, we started with 50, then with 100. Now we have got 800 meters integrated on pan-India base. Imagine 800 meters. Okay. So this is all very slow approach.
I have a personal question. Were you like this since beginning, or there was someone who has mentored you into thinking like this, or this is your own inner calling? That you went so deeper into analysis of data and managing all the campuses of Godrej?
Okay, this is a very tough question. But let me tell you, yes, this has grown over a period of years. Now, what happens, what I observed during my tenure of working, most of the time, what we do is we install a new air conditioner, new compressor, new pump. Okay. How do we see that the pump is performing to the design what has been given? So what we have got one small data logger where we put for 24 hours, maybe for 3 days, 5 days, and then we come back, we download that data. So 3-4 days data we go. But after 15 days, after 1 month, what happened? And we started doing a surprise check after 1 year. And we found that same data analoger was throwing up some very, very important questions that the performance has really drifted very badly. That is a time it was like a call to us that see, on the day one, on the 1 month, 2nd month, 3rd month, 6th month, when the systems are new, we are getting some good amount of our information. But what happens after 1 year, 2 year, 3 year, that efficiency which we are talking about, say 80%, are you really getting 80% efficiency? Okay, it may have drifted down to 50%. So how do we address that? So that is the time which we started thinking over as a team also, under my guidance or whatever. We also learned that we must have some sort of a system which will give us an online monitoring system, as I showed you about that compressor last slide. In the month of August and in the month of December, we are seeing this consistent performance and without any human intervention, because today everybody is talking about reducing the manpower. So ultimately, we will have to have some sort of a quantitative numbers in front of us, analysis. So this is when we started scouting for the system. And then we had a tough task, tough challenges. We had a lot of presentation from high-end companies. And we said, yeah, we will not be utilizing the system, which they got a lot of features. They got lots and lots of features, but we may not be able to utilize. So why spend money, sorry to say, if I have to drive a car, why I should buy an aircraft? See, aircraft taxis on the runway, but ultimately it flies. Okay. But if I have to drive a car, then let me look at the car only, a high-end car. Let me look at Mercedes, but not buy a Boeing, something like that. So analogy goes that way. So this is how we did a lot of analysis. We had a lot of presentation, and this has been going on for a long time. So slowly we latched on that, yes, now this is something appropriate, and we are slowly scaling up. We are doing a lot of other analysis. And it is not energy meter, let me tell you. We are putting water meters, we are putting gas meters, we are putting air meters, any metering device which has got a 485 output, which will talk, that's it. So any meter will do.
Great, great. Next question is, sir, from Umesh Malaya. He is also faculty at CTES College of Architecture. He's asking, electrical bills for residents, for example, given overall consumption, how can we know the usage of each room for kitchen, bathroom, etc.? Is there some way of knowing energy consumption for each appliances? Appliance, we know energy consumption, but can we know the energy consumption of each room in a small 3 BHK home also?
It is very difficult. I'm not saying impossible. The cost will not justify. The cost will not justify. There are meters which are available in the market. Okay. The other way is, I don't know whether you are aware of it. I will share with you afterwards. Just now, I don't have the details. There is a plug-in device which is available in the market for a very nominal cost. I think so, 2,000, 3,000. And that plug-in device, you can switch from one plug to another, to another, to another. But only thing, you should have a plug-in thing. See, for example, if you want to see how much is your geyser consumption, the geyser should have a plug. So you plug in that device, it's a meter, and in that plug, there is a socket. You put that plug. That same plug, you remove it, you put it for your window AC or a split AC, and you put that plug. Okay. So you go on shifting from one device to another. This is a very simple device, cost-effective device, which will tell you how much is your load, how much is your consumption, etc., and all that thing. But if you want to do permanent monitoring like that, it is a bit difficult, and it is also costly, So that is why things have not materialized. But if you got a large flat, so and you got large mansion, like high-end apartments and all that thing, those devices are there, but cost justification will have to be there.
Okay. Another personal question, sir. Do you do an energy monitoring of your home also?
No. No.
No?
No.
Okay.
No, energy monitoring of my home, that is my personal home.
Yeah.
Oh, okay, that I can share with you. Of course, definitely I look at my energy bills, and I'm sure everybody knows now, it is very common that you have got this BLDC fans, ceiling fans available in the market. Atomwork, super fans, they are available on the Amazon also. And Bureau of Energy Efficiency is also advocating. So long time back, around 3 years back, fan is one common thing which you run even in the winter, maybe because of mosquitoes or whatever reasons. And even when in the summer, when you sleep, in your split or a window AC, if you put it at 26, 27, and if you run your fan at speed number 1 and 2, these BLDC fans are really super efficient. At a full speed, it consumes anything from 28 watts to 35 watts. Again, a Bureau Energy Efficiency fan of 55 watts. Again, your old fans, which you go home today, they will be consuming 70 to 75 watts. So this, I've changed all the fans in my home some 3 years back and put LED lights, because most of the time they are on, most of the time. And I could see the benefit in my bill. But not room-wise, not device-wise. And I'll share with you or Roshni madam that device, small device, which is available in the market, which you can share later on.
Sure.
So I've got that thing with me. So that I purchased. So whenever I have a doubt, I do that plug-in. And even your washing machine, you'll be surprised when it is doing spinning, when it is only doing the wash tub running, and when the water is coming, you will see a lot of difference of energy which is being consumed.
Oh.
Yeah. So, but you should have a plug-in device. If it is directly fitted inside a switch, then you cannot do it.
Okay.
So that is something which
I
we'll have
think
to do a little bit of a change.
for
Yeah.
quite a few of the single phase devices now you can check it and even remotely monitor it. I know quite a few people like the startup people who are
Yeah,
doing
yeah,
this
yeah.
kind of thing.
Only thing that cost justification will have to happen. That's it.
Yes.
Maybe after 3 years, this will become a very conventional, common device like your mobile.
Yeah, yeah.
And you can definitely find out that this is the rated capacity of your AC, for example,
Yeah.
and what it is actually consuming. So
Yeah,
then there is
correct, correct, correct.
efficiency is not there because you have
Yeah.
not cleaned it, you have not
Yeah,
made
yeah,
it.
yeah. You can see after cleaning also, after service. So
Yes.
that device I will share with you because most of the AC systems are plug-in.
Uh-huh.
So this is where I have tried out. I will share with you these details.
Yes. Sir, one more question is there from Divya. She's asking, where is energy monitoring more efficient, in commercial or residential segment? Where is the most impact felt amongst the two, residential or commercial?
See, here it is very obvious that if I take 20% of 100 and if I take 20% of 50, obviously the numbers will be there from the 100 or 20% will be more. So in commercial, what happens, the loads are significantly high. And also the operations are also sometimes 24/7, be it a IT sector or a data center, if you see. Significant load. Data center
Yeah.
is very heavy. Okay. In residential, yes, whenever now these green buildings are coming up, we are trying to inculcate the culture that basically common loads. See, pumps. Pumps are the silent guzzler. If you see in any building, which is a 30-story or a 20-story, they've got a hydro-pneumatic system or a top storage system, and ultimately the water comes by the gravity. But ultimately, pump is really a major consumer. Second thing, if you see the elevators, now people have got 3-4 shafts and they've got 3-4 elevators. And now also people have got the intelligence systems also built in. Now, if you see a lot of elevators have got those regenerative type and so elevators is the second part. The third part is your common area lighting, gardens lighting, and then your facade lighting and your lobby lightings and all that thing. So in green building, mostly we advocate that these are the loads which you must meter and try and put a small energy monitoring system where at least you have an accountability, because ultimately that gets loaded to the people as a common area charges. That is, you agree upon that.
Yeah.
So residential, these are the merits. And if you implement these systems which I talked about, and there is a facility people obviously monitoring the energy performance of the residential, I would say it will pay back for the money which you are spending about.
Yeah.
And there is a good potential. Okay.
Yeah.
So if you want to experiment at one of the places, we would be glad to assist with you and make a case study out of it.
Yes. Another question is from Nikhil Devkar. He's our ex-student and he's accredited professional also. He's asking, in order to encourage real-time energy monitoring, can the green building certification platforms provide additional points, merits for such comparative analysis over number of years?
Yes, I think so. That is my passionate subject. He has really instigated me. I have been advocating this and saying, yes, this should be there, and we must make this data also public. See, the reason is many times people are skeptical because of the trust. See, today I've shown you everything on figures very clearly,
Yeah.
and things are coming from the system. If I don't show you those graphical dashboards and widgets and all that thing, correlate with the reports, and these reports are really getting generated from the system, not to the Excel. So this is what we have institutionalized, and it's not an ad hoc or a one-time approach. And so this reports also, we are trying to get it more and more refined. So yes, this should be, I'm trying to put it across to CII also, talking to them, even in ISHRE forum. Okay, I have been told to make this presentation, but this is something which we are making it ready. So again, maybe in ISHRE, we will be making this presentation. So yes, the point is very valid. Some sort of a really serious thought of this data analytics, and on that should be given, and the weightage should be given. to show that consistently. And this is true when you go for existing building. See, if you see the existing building, and CI has also started this operational efficiency excellence awards. Okay. So there also things are being asked. In fact, we won this efficiency award last year only in August during the lockdown for this building, this plant 13 building. So people ask that where is your data management system and what is the rigor? And this rigor will only set in once you have got this automated system. Manually, you cannot do it. Because see, let me tell you, in this plant 13 NX building, we have got 48 meters. Now, 48 meters, you tell me to read it manually, it will from dawn to dusk. You know, that fellow will be only reading the meters. And God alone knows how many mistakes he will make. And then somebody will have to punch that data into the Excel. And then how do you do the analysis? This is an hourly analysis, which you get automatically.
Right. Sir, one more question is from Rishabh Joshi. He's asking, can you share some case study for chiller, sir? Chiller plants design. Some case study he's asking.
Chiller plant design. Actually, I am on the other side of the fence. I am not a designer. I am the operations guy. I am the maintenance guy. So once the facility up and above, we do the monitoring. But designing is something very different. I'm sorry, I will not be able to address because I'm not into design. In fact, we hire consultant. We take help of people to do the design of all the systems whenever a new facility comes up. We hire people and we just only vet it. We don't vet. I'm not into the design part. There are different type of softwares, different type of people. That is, I know there are 24-hour analysis. Carrier has got a software and all that thing. So I'm aware of it, but I have got any hands-on experience, so I will not be able.
Roshni, would you like to chip in something? We are at the end of question and answer session.
I think no. I think most of the things are covered.
Yeah. So thanks a lot, Rumi sir. It was a wonderful and enlightening presentation. It opened our eyes towards data. Like they say, data is the next God. So we know that God tells you to take care of things. And this is how the data has to be analyzed. And it's a wonderful, meticulous planning and analysis that you do. From on behalf of IEAR, CTES College of Architecture and ASSOCHAM, I really appreciate your effort and I thank you. I hand over to Pushpagandha for a vote of thanks. Pushpagandha.
Thank you very much. In fact, it was a pleasure to give this presentation. I hope it has been useful and I've been able to articulate it to the expectations of the participants over here. Yes. Sorry, I am not much from an architectural background, so I get a little bit sometimes carried over on the engineering part,
No, sir, but data is has to be analyzed by everyone,
right.
Not only by. I mean, architects also go through a lot of data. Yeah. They need to understand the analysis and how do you reach to some conclusion. Yeah. And it was a wonderful presentation. I don't know. I hope you have not taken it in the wrong way. I said Rumi Engineer.
Yeah,
and a wonderful engineer. That's what I meant.
Maybe that's a coincidence.
Yeah.
Okay.
Thank you, Alka. Yeah, thank you. I would like to give the vote of thanks. We are coming to an end of a wonderful session. I must first thank Rumi Engineer sir for giving us an insight into the operations and the maintenance systems that look into the energy efficiency system for any kind of a working building. And it was as if the machines were talking through their data to us. You told us the language, these machines could take up for the energy efficiency systems. Thank you once again, Rumi Engineer sir, for a wonderful presentation.
Welcome. Pleasure.
Yes. I would also like to thank Dr. Roshni Yadua for making this session possible. This was a session which was initiated on your behalf as a program, and it was something that was a collaborative effort, but a lot of learning as architects for us comes from this background of engineering, environmental studies, and the supporting areas. I would like to thank Professor Alka Tavri for moderating today's session, and the entire team from IEAR and the team from CTES that made this technical aspect of today's session possible for all of us. Not the least, but our other associates, I would like to thank and extend our thanks to Architect Rajiv Taishete, Vice President IEAR, Secretary ASSOCHAM, GEM Maharashtra Chapter, for his support and guidance. I would also like to thank Architect Vilas Outside, Chairman of ASSOCHAM, GEM Maharashtra Chapter, and the National Council Chairman, Mr. Pankaj Dharkar. Last but not the least, the event would not have been possible by the chance of just collaboration of all these three agencies, but very much by the team that put this entire session together. A big thank you to all our participants who stayed with us throughout the day 2 of the webinar series. We would like to make a reminder of the third day of the session tomorrow, which will also begin at 4 p.m. Please join us by clicking the same link that you have been shared with, for which also you must have used it. We would also like to thank all those who were the part of our virtual family for the support you extended through the various social forums, and who are not able to access it only through the Zoom today, we're also able to access it through Facebook and our Instagram pages. Please look forward to the updates. Please join them and post it to your various other forums together along with it. Please subscribe to our YouTube page and do check our past webinars also. We thank all of you all for joining for today's session. Please take care and stay safe. Bye, everyone. Thank you.
Thank you very much. Thank you.
Bye-bye.
Bye-bye. Thank you very much.